everyone. So today we are starting to talk about solving one-step equations with adding and subtracting. We're just starting to talk about it. We're going to take it in tiny little bites. When you're actually solving one-step equations, there's some steps. That's why it's called one-step or two-step equations. And we're going to get to that later. But today I want to have some visuals in our brain about what equations are. So what an equation is you can think of it, if you see this scale right here, you can see this scale. I want you to think about equations like a scale where we want them to be perfectly even. We don't want one side higher or heavier or lighter than the other. We want them to be perfectly equal. They are equations. Both sides of the equal sign should be equal, should be even. So we need to make sure that we are keeping our scales balanced. And when you think of an equation like this, a lot of the parts and a lot of the steps will make sense that we have to follow to solve them. So in the future, we're going to learn the actual steps to solve these equations. But for right now, we're going to just try to understand what's going on with them by looking at some examples and kind of using some pictures to get used to what equations are. So we are looking at one-step equations with adding and subtracting. This is just the introduction. So I want you to take a look at this. And I want you to kind of notice what's going on here. What is going on here? I see I've got a box and I've got a 1. And on the other side, I've got 1, 2, 3, 4. So we can think of this like an equation. And in the center of this scale is an equal sign because these are equal. The sides are balanced. You can see the scale is balanced, so the two sides are equal. So we want to kind of figure out what would have to be in that box to make these equal. So I think to myself, okay, I see that there's 1 right here, but there's 4 over here. So think, what would have to be in that box? Maybe even pause the video if you want to take a second to think about that. What would have to be in that box to make these two sides equal? Well, I know that there's 1 right here and there's 1 right here. So what's left over? The box must equal, this box right here must equal these 3 1s right here. So what's inside the box must equal 3. Okay, because in order for those both sides to be equal, this side needs to equal 4, just like this side equals 4. You would need 3 more of the 1s to get to 4. Okay, so that's a way to look at an equation. Another example is this. Think about what that red circle would have to equal. So again, I'm looking at it and I'm noticing that there's 1 over here, and this side also has a 1. In order for those two sides to be equal, balanced, what would the red circle have to be equal to? Remember, there's an equal sign. You can imagine an equal sign. The middle of that scale is of the balance scale is the equal sign. So the red circle, this red circle must equal 2 because that's what it would need to be equal. Okay, now we're mostly going to be using variables, and you guys know for the parts that we don't know. So you guys are used to variables. Variables are the letters that stand for something when we don't know what that something is. So let's take a look at an equation that actually uses a variable. So this equation actually uses a variable, and that's kind of we're used to this. This might even look more comfortable to you than the ones with just the pictures, because we've been talking about variables and stuff a lot. So I want you to, again, if there is plus 3 right here and plus 4 right here, positive 4 and positive 3 and positive 4, what would x have to equal for that scale to be even? What would x have to equal for that scale to be even? Well, if this side has 4, and this side has 3 and then x would have to be 1. The other thing that we can do is we can write this as an equation. And this is really cool. I'm going to, again, use my middle part right here, my balance point of the scale, as my equal sign. So I'm going to write an equal sign up here. And I'm going to write this equation. And what this equation says is I've got x, here's x right here, x, and then I've got 3, a positive 3, so plus 3, x plus 3, and then on this side of the equal sign, on the other side of the scale, I have 4. So my equation, maybe I'll write it a little bit neater, my equation is x plus 3 equals 4. So that is the equation that is represented by this picture. Now, again, if I want to figure out what x equals, I've got to figure out what I would have to put in for x to make it true. So in order to get 4, x would have to equal 1. Okay, so x would have to equal 1. All right. Another example, and you guys, it doesn't matter what side of the equal sign the x is on. We can do the exact same thing. So if the x is on the other side, we still know that that's equal. We still know that the sides are balanced. We just put x on the other side. Now we've got to figure out if there's 6 over here, positive 6 over here, and then 1 plus something in this x box, we've got to figure out what we would need to get x, or to get that even, what x would have to be to make that side even or equal to 6. So how many more would I need from 1 to make it equal to 6? Well, if this side has just 1 and I need it to be even or equal to 6, it would be 1, 2, 3, 4, 5, 6. Right? So let's write the equation and check and see what we think then. So this equation says have an equal sign in the middle. Equal sign in the middle. On this side of the equal sign we have 6. On the other side of the equal sign we have x and then a positive 1. So this says 6 equals x plus 1. 6 equals x plus 1. So if 6 equals x plus 1, we got to figure out what can we add 1 to get 6. And we already kind of figured out we would need to add 5. Actually, let me write it nicely. Let me write it actually how we'd write it for algebra. X would have to equal 5 in order to get 6 and be balanced. So we would say 5 must equal x. You can also swap those around. You can also say x equals 5. As long as you keep them even, you can swap the sides around. When you're still solving it, you don't really want to swap the sides around, but we can in this case. Okay, now we can do the same thing with problems that involve subtraction. So let's start by writing this problem out. So on this side of the equal sign, here's our equal sign. On the left side of the equal sign, I've got x minus 2. And on the right side of the equal sign, I have 1. So this equation is x minus 2 equals 1. Now, when it's subtraction, you have to be careful. And you have to be careful always, but just think really, really carefully. What can I take 2 away from and get 1? So it's kind of like, what has to be in the box that you could take 2 away from and still have 1 left in the box? So another way to think about it is you have some money in your pocket. That's kind of like X. X is the money in your pocket. Miss Howard comes up to you and takes $2. In your pocket, you still have $1. How much money must you have started with? So think about that. Maybe even pause the video for a minute. So in order to take away 2 and be left with still having 1, x would have to equal 3. And if you think about it, it makes sense because 3 minus 2 equals 1. Okay, so you would write that as x equals 3. And it makes sense, again, because if you put this 3 up for the x, it would be 3 for the x minus 2 equals 1, which is true. 3 minus 2 does equal 1, so that is correct. X must be 3. All right, one more on this. Okay, looking at this picture, we're going to write the equation first again. It's really handy to be able to write the equation first. So here's my equal sign on the scale or on the balance. Here's my equal sign for writing the equation. On the left side of the equation, I have 2. On the right side of the equation, I have x minus 3. So again, we've got to think about what could be in this box that you could take away 3 from, and be left with still having 2. So if you start out with some money in your pocket and Miss Howard takes $3, but you still have $2 left, how much money must you have started with? Think about that for a second. What would X have to be? How much money would you have had to start with to take away 3 and still have 2 left? If you said that you would have had to start with $5, or that there must have been 5 in that box, that is correct. So think about it like this. 5 minus 3 equals 2. And we can read it the other way. 2 equals 5 minus 3. Okay? So then, again, we have to write it, make sure we know that we're saying what x equals. We have to answer and tell, what does the variable equal? Well, x equals 5. You can write it like that, or you can write it like, you write it smaller. You can write 5 equals x, or you can write x equals 5. It doesn't matter which side you put each thing on, as long as they're equal and you know what x equals. Okay. So you're going to be answering some problems like this today. Do your best. Make sure you're paying attention. If it says minus a number or plus a number, you're only doing adding and subtracting today. Do your best and maybe come back to this video and refer to it if you need any help.